Hello, everyone, and welcome to the Electric Education Center, session number 4 on receptacles. This series is going to round out the GFCI and the AFCI talks of sessions 2 and 3. Let's start with a little bit of history. Receptacles were first available in the 1880s, about 15 years after the Civil War ended. I was not there. An early American electric plug and socket was invented by Harvey Hubble and patented in 1904. He then patented a parallel blade lug in 1913 and a polarized version in 1916. The polarized version is what we use today, and it has one wide blade for the neutral and one narrow blade for the hot conductor. There wasn't much change for the next 50 years or so with receptacles, but when it happened, it was a big one. So what came into design was the stab-in or the backstabbing style of receptacles. And, I did a little bit of research on this subject online, and some of the questions and comments you find on some of these electrical forums are hard to believe. And some of them are actually quite scary with people giving you bad information. So careful what you read. In the beginning, you could use 14 gauge on a 15 amp circuit breaker or 12 gauge on a 20 amp circuit breaker for these backstab receptacles. The problems developed mainly with the 12 gauge conductors because of the amount of electricity they carried and the fact that when the electrician would stuff the receptacle back into the box, they were actually stressing the contacts that were inside the receptacle. And then just simply too much stress on the blades, and this led to burnouts and failures. So that's why today these backstab receptacles only accept 14 gauge conductors. Believe it or not, people will still try to stuff a 12 gauge conductor into a 14 gauge hole and wonder why it won't go in. My recommendation is that you never ever do any backstabbing of receptacles. It's not the most professional way to do it. So don't backstab ever. When you find a house with receptacles connected this way, I suggest that you could recommend rewiring of every receptacle in the house. In this day and age, you should not be doing any backstabbing of receptacles as a professional electrician. I did an inspection of a brand new home in New Jersey after Hurricane Sandy, and they built this 3-story home ground out. And I went to I did the rough inspection, everything went fine. And then I came back for the final inspection. And half of the receptacles would not read or would not read correctly with the 3-prong tester. So I popped out a couple receptacles and I took a look at them and I see that they're all backstabbed. Brand new home. So I said to the homeowner, I said, look, this is not the right way to do it. I suggest you call your electrician and get him back here and tell him to wire it the right way and put the wires around the screws on the sides of the receptacles. So he did, and the electrician did, and then I went back for the final, and every receptacle read perfect. So connecting a duplex receptacle, just remember there's 2 different color screws on the receptacles. All right, you have the black wire going to the hot conductor going to the brass screws, and the neutral conductor going to the light colored screws. And an easy way to remember is connect the black wire to the brass screw and the white insulated wire to the light colored screw. So it's black to brass and white to light. Very easy to remember. Black to brass and white to light. Today's receptacles, generally every receptacle installed in the interior of new home construction is going to be the grounding type with 3 prongs and tamper resistant. Note that they are not tamper proof. They are just tamper resistant. I'm going to demonstrate a tamper resistant receptacle in a few minutes. Remember, as an electrician or inspector, to go to every receptacle on the project when it's done and do the polarity check with your tester. Believe it or not, I did an inspection. They changed an old warehouse into condos for senior citizens, and I had to check 196 receptacles. Well, 195 read perfect, and the last one, number 196, was reverse polarity. you cannot, as an inspector, go in and do 1 out of 5 or 1 out of 10. When I hear that kind of stuff, I just cringe. So be sure to check all the receptacles on the job, every one of them. It's your job. That's what you were hired to do an inspection. So you check every receptacle. Receptacle orientation on this job. Okay, should we put ground pin up, or should we put the ground pin down? Who cares? I don't have a preference, but some people do. Owners, engineers, designers, and the job specs can all demand that the receptacles go in a certain way. The National Electrical Code does not get into it at all. But a word to the wise and a tip for the day: before installing 270 receptacles in an office space, be sure you see it in writing as to what orientation it's called for. That is a true story. Special locations and special conditions. Let's start with tamper resistant. As I said, when installing new receptacles in home, they're all going to be required to be the tamper resistant type. Now, there are some exceptions, and go to NEC section 406.12, 406.12, and the tamper receptacle information is there, and it will tell you that these tamper resistant receptacles are also required in guest rooms and guest suites of hotels and motels. They're required in child care facilities, preschools, kindergartens, waiting rooms and clinics like doctors and dentist offices where kids would play, places of awaiting transportation like airline terminals. They're also required in gymnasiums, skating rinks, and auditoriums, dormitory units, assisted living facilities like where the grandkids would go to visit the grandparents. And all these terms that I just went through, most of them are in Article 100 definitions in the National Electrical Code. So be sure you know what you're talking about. Be sure to offer this upgrade as a service to your customers also. In any case, as an inspector, like I said, and as a service electrician, be sure that all your customers on your contact list know that replacement receptacles have to be the tamper resistant type. So let's talk outdoor receptacles for a minute. Any outdoor receptacle, new or replacement, has to be of the weather resistant type. It has to have a WR stamped into the body of this receptacle. You've all seen receptacles on the outside of houses that are like dried out and sun-baked and cracked. Well, the new type required today is weather resistant and sunlight resistant. They're built to a higher standard. So the new WR style is made with nylon or high impact thermoplastic. It's very strong and weather resistant. So if you're replacing an outdoor receptacle today, it's generally going to be a GFCI type, WR type, and a TR type, weather resistant and tamper resistant. Also remember that the outdoor wet location receptacle covers have to be extra duty type, and that means it should say on the cover extra duty. So I have a bulky cover here, but you get the idea. It says right on it, extra duty. Now to me, extra duty means that it's normal, that it's just strong enough not to break up. So make sure your outdoor receptacle covers say right on them, extra duty. Now remember that the outdoor GFCI type I just talked about is a Class A device. It's supposed to trip at 5 milliamps plus or minus 1. So you'll see these things listed as 4 to 6 milliamps on these receptacles. Find and replay session 2 of this series to get more detailed information on ground fault protection. It's time for the middle 8 minutes where I answer questions from the previous week. I got a comment, and the comment was, Rich, it might be better to install a dual-purpose AFCI, GFCI type receptacle outlet in the first receptacle serving the dormitory room, as it would save a whole lot of calling a maintenance man 24/7 to be resetting these circuits. So personally, I think it's a good idea, and maybe some architects, engineers, and electric inspectors might want to chime in on that and let me know what you think also. Also, another question that came up, I'm going to show you some examples of when AFCI protection would have come into play. It's a short middle, 8 minutes, I know. Now let's take a look at split wired receptacles. There are some situations where a contractor, electrician wants to split wire a receptacle. Prime example would be to plug in two different appliances that cannot be connected to an individual branch circuit. In this case, you would break the tab and take one hot conductor to each of the two brass screws. All right, this is a split wire here, and I'll be showing this again in a second. But you can see that the tab is broken between the two screws. You can see that the tab is still intact between the two screws on the neutral side. But on the hot side, we have broken the tab, and we've connected phase A to one screw and phase B to the other screw. It's in this case also spelled out in the NEC section 210.4. If you're continuing on to another receptacle, you must pigtail the neutral connection so that if you ever have to replace this split wired receptacle on a multi-wire circuit, you won't be breaking the neutral to the rest of the circuit. So you're going to have to pigtail your neutrals, all right, and then come to the screw, the neutral screw, one time. You're also going to need to install a 2-pole breaker that has factory handle ties, not some piece of copper that you put between two handles or a 6-penny nail or something like that. No, it's got to be a factory handle tie so that both phases of this breaker, it's very important because it's a dangerous situation if you don't do this. It's very important that you both manually turn off both sides or automatically, if the breaker trips, both sides have to trip. Some other special situations, switched receptacles are used in several locations. According to section 210.70A1, 210.70A1, a habitable room in a dwelling unit shall have a wall switch to control a lighting outlet. This lighting outlet can be a ceiling or a wall lighting outlet, or you could switch a receptacle. Now, you're not going to switch both halves of a duplex receptacle, or you shouldn't, because receptacle spacing rules require that there's a receptacle always energized and that no point along the base of the wall should be more than 6 feet away from this energized receptacle. So unless you're going to install an extra receptacle besides the required ones, it's best just to split wire just one duplex receptacle and provide a place to plug in the lamp. Now, when the homeowner enters the room, they can either light the ceiling light or the floor lamp or a table lamp simply by flipping the toggle switch at the entry location. So this type of lighting outlet control requires a 3-wire non-metallic sheath cable. For example, when wiring a dwelling unit, you have the requirement to have a neutral wire installed in every switch box, and I know there's exceptions, so just read that section in your code book. And to connect that split wired receptacle, you're going to need to bring in a always hot conductor and a switched hot conductor from the wall switch. Then, like I said, break off the tab on the brass side of the receptacle, and then connect the switched conductor to the bottom half of the receptacle and leave the top half hot all the time. That way there, it's convenient for the homeowner or the user who's plugging anything in. They won't be fighting to get underneath the lamp that's plugged in, for example. So let's talk about the best selection for the switched receptacle location in a bedroom. Let's say we have a bedroom, 4 walls, small enough that there's one receptacle on each of the 4 walls. Which receptacle should you switch of the 4 in that bedroom? Well, some contractors will control the receptacle located closest to the switch. Some contractors will control the receptacle that's farthest away from the switch. Some contractors won't use their head at all, and they'll control a receptacle that's located behind a door swing. Some will go through the trouble to control the bottom half of all 4 of those receptacles. I don't usually advise to do that because I think you lose too many usable receptacles. But anyway, one trick that a contractor used on a job, I was inspector of record was this. Whatever receptacle she split wired for lamp control in the bedroom, she would turn it opposite orientation from the other three. So if the other three were pinned down, then the one that she was switching was going to be installed pin up. Then when the homeowner moved in, they didn't have to go through the trouble to find out which one it was by trial and error. They look at the four of them. The one that was different from the other three is the one that was switched. Very simple. Now let's talk about some quality receptacles that are used for commercial installations like hospitals, schools, and office buildings, among other places. For the hospitals and some healthcare facilities, I'm going to refer you to the National Electrical Code section 517, actually Article 517. Specifically, section 517.18b1 and b2. They require that any receptacles that you install within a 6-foot radius of the patient bed location be hospital grade type. These hospital grade receptacles are going to be marked with a green dot. I'll show you in a couple minutes. What makes it hospital grade? Tougher construction and strong blade holders in the receptacle make it hospital grade. We don't want an important plug to pull out easily from a receptacle like that. We also don't want a plug to pull out when a doctor or a nurse or a cleaning person kicks a cord or steps on a cord. And you don't want to automatically install hospital grade receptacles in every room in a hospital, like offices or waiting rooms, because generally there are no life-saving machines plugged into any of these rooms. And also the receptacles cost around $20 each. And I've seen them online listed for as high as $60 each. So they're very expensive. You don't need them everywhere. You need them within 6-foot radius of the patient bed location. All right, let's move over to the demonstration table. I'm going to take a look at some articles I have over here. We'll take a look at some Path and Seymour Legrand commercial receptacles. Receptacle I want to show you is an Eaton product, and this is a GFCI type. This has a test and reset button. It has 2 indicator lights here that will tell you to replace if it's blinking. All right, and the thing I wanted to show you on this, you know, a lot of people may not realize this, but the yoke connectors here can be used as a wire stripper, okay? And it's not that easy to use, but I'm just telling you that there's one here for 12 gauge and one here for 14 gauge. So you can do your thing. Next item I have here, I wanted to show you the 3 ways that you could create an arc. Remember from last week, the arc fault talk. And here's a situation where you have a screw driven through a Romex non-metallic sheath cable. It made contact with the black conductor here. And then if you go into a metal stud or wood stud, you'll still create a path for current, which will eventually cause some type of arcing and some type of a problem. That's the thing you run into. Next thing I have here is, well, this is the best side of the wire nut, but you can see here from a hot connection, a loose connection, this overheated so bad it corroded and chewed away and melted this wire nut. So that is another example of an arc fault situation. And then this here is a wire that I got from a friend of mine, actually. He said, he called me up and says, Rich, he said, my shed out in the backyard only has electric when it rains. No kidding. All right, so you can see what originally maybe a shovel nick or something like that turns into this type of a problem. And an arc fault circuit breaker would have sensed that and stopped. Now, if this was in a house, for example, something like that, for example, it could very easily start a fire with the amount of heat that was there from the arcing. All right, next thing I wanted to show you is this is a Pass and Seymour demonstration model. And with these tamper-resistant receptacles, you'll see they have a paper clip on here, and a single paper clip will not go in there. And they show a key and a paper clip and a nail file and a bobby pin, and any of those items that a kid would want to play with and stick into the slots will not go. But when you enter two prongs at the same time, all right, you can see that they go in very easily. And they compress the spring and the shutters move to the side, and then there's no problem. But then again, you try to put in a single item, will not go. Tamper resistant. As it says here, 7 kids per day are injured by contact with receptacles. More than 24,000 over 10 years. All right, and it also says here, this is safer than the plastic outlet. All right, so here's the plastic caps that we're talking about. And people will buy these things at the dollar store, whatever. But as you can see, you know, they're easy to take out. A kid could take them out. And also they get stepped on, they get broke, they get lost, they roll underneath a chair. And then guess what? You have no tamper-proof protection now. All right, so get away from these. Recommend to your customers that they install tamper-resistant receptacles throughout their whole house. The other thing on this receptacle is the split wire that I talked about before, with phase A going to one side and phase B going to another. You would break the tab here, and on the neutral side, because we don't want to break the neutral of this multi-wire circuit, we would pigtail our neutrals and take one connection over to the screws. That way there, when you have to replace this receptacle, all right, you would just be breaking this connection here to the receptacle, but your main neutral will always stay together. The other thing you want to do is test the receptacles, especially for your customers, if they have new appliances going in that they want to plug in. Do your tension checker test, and you can see on this one here that holds on that side. But if we test this loose connection here, set them back to 0, pull through, you can see that one blade does not meet the requirements. It only holds to 16 ounces. The other holds over 24 ounces of strength there. But again, this will show you that you have a weak receptacle. You also check the ground pin side, okay? And that ground pin reads good, as does this one here. All right, so check the receptacles. How many do you want to check? Check them all. All right, next item we have is Pass and Seymour was nice enough to come out with this demonstration package here. And the first receptacle here is tamper resistant. You can see the shutters in there. It's also got the green dot. It says it's hospital grade. And then you have, you could feed in and feed out from this device. And it's marked TR, tamper resistant. Next item you have is another tamper resistant receptacle. You see the shutters in there, but this one here has 2 pilot lights here that will tell you that the receptacle is energized. And then there's no guesswork whether there's power at a receptacle or not. Another nice device. Feed in, feed out. The next one here is the surge suppressor type. They have to be blue. Again, with the green hospital grade dot on there. There's an alarm here that you can shut off, okay, when it goes off and tells you that there's been a surge and the receptacle is compromised, for example, and the alarm is going off. That has an off button here for the alarm. It also has a flashing red light that would tell you that there is no more protection, and that it's time to replace this receptacle. Now, when it's time to replace this receptacle, the electrician at the hospital would have to go to the circuit breaker panel and hope that this receptacle is marked as receptacle E4. So you go to the circuit breaker panel and you find receptacle E4 and you turn off that circuit breaker, but you find out that you turned off 3 or 4 other receptacles, maybe even in another patient room. So what Pass and Seymour came out with is this invention here. And this is a pre-wire block that you would insert into the receptacle and make the connection that way. So this block is wired in at the rough-in stage, black to black, white to white, green to green, and then it's stuffed back into the box. And then after spackle and painting and all that, and it's time to device out, you would bring these and bring this out and snap it in, and it's going to lock in. Then should this surge suppressor type receptacle give up the ghost and you want to replace it, well, guess what? You don't have to go searching for that circuit breaker anymore. You could just go to the device, release it, replace it, and put the new one on and stuff it back in the box without ever disturbing anybody else or turning off any other circuit breakers. This device here is finger safe in that you can't get to the hot conductors without working at it, okay? So that's what this is for. Then we have a single receptacle here. It's just made to feed in one time, and that's it. No downstream protection or anything like that. No downstream connections. And this would be, again, the green dot. This is for 15 amp or a 20 amp with the T slot, 125 volt receptacle. The next item Legrand has is a emergency type receptacle. This is the signal that this is on a emergency circuit, like when the main power to the hospital is lost from the electric utility, then the generator is going to kick on, and these receptacles are the ones that would be energized. And this particular kind here also has a pilot light, which would light this up. Maybe the lights are out in the hospital and not back on yet, but the emergency receptacles would be lit with a pilot light. Next item is a one-time come-in connection, and that's it, because there's no room for anything else in this receptacle, because it's the USB type. All right, so we have 2 receptacles and 2 USB. All right, so you would come into this receptacle one time, either pigtail your connections in the box or come down from a ceiling box and make your connection one time and be done. All right, the next item you have is hospital grade plugs and caps also. And if you have to make a cord, you would have to use these devices if required. Also, next item here is a GFCI. It's got a test and a reset button on there. Also, it has a nice pilot light here that tells you it's energized, and also has a red indicating light here, and it says replace if blinking. See, these receptacles, they test their own circuitry every 5 seconds or 10 seconds, depending on the manufacturer. And if their circuitry is compromised in any way, they will not energize. And then it will give you a signal here, red light is flashing, and it's time to replace this receptacle. All right, this is a line side feed in and a load side feed out downstream, if that's the situation. So you have that product there. Then they have their normal everyday receptacle tester, all right, and you would plug in and read your lighting pattern here. If you get a green and a yellow, that means it's correct wiring. Any other pattern means that there's something wrong. But this tester here, okay, from Pass and Seymour, also does the testing of the tails. So you can test your tails before you even finish up with your rough. Okay, so in other words, somebody could go around and test these. All right. Oh, I want to show you this also to try to include everybody. This is a hospital grade receptacle from Leviton. It's called a Levlock. And on this style item I want to show you, this is Levlock by Leviton. This is their style. And what they have on here is some pins on the back of the receptacle that you would put this plug-in device here and lock it in. Okay, that's their style of hospital grade quick wire on the back. When you want to replace this device because it's broken some way, all right, then you would just unplug it this way, replace it, get the new one, put it on, lock it in, and stuff it back in the box. Again, without ever having to turn off a circuit breaker or inconvenience anybody. Okay, so there's a little bit about my experience with receptacles. If you have any questions, send them to richvanwert@gmail.com. I'll see you next session. Van Wert out.